Hello students, welcome back to OrganiChemVerse. I hope you all doing well. In this video, I'm going to solve one more interesting organic chemistry question based on your IIT JEE Advanced level syllabus. Now, what is the question here? That you have to observe the given three molecules and their structure and then choose the correct statement or statements from the given options. Now, what are the molecules here? They are morphine, codeine, and heroine. All these molecules are related opioid molecules. So what do you mean by opioid now? So the opioid molecules are the drugs which are derived from the opium poppy, which is also known as poppy seeds. Now, what is their importance? They are mainly used in the medical field as painkillers or the pain relievers, especially when people meet with an accident or when they undergo surgery, right? So they usually use these molecules as pain relievers. How they are related? Definitely they are related by their structure. You can see this is their core structure, right? And you don't have to remember this, okay? The question is about the functional groups here, right? So you can see when hydroxyl group is attached to benzene, nothing but this is phenol and this is an alcohol, whereas here it's a methoxy group, right? It's an ether and alcohol. So that's how they differ in their structure. What about the heroine? Heroine here, there is a acetyl group, same as here also. That means what? They have a core structure which is similar. Only the functional groups here are different. Okay. So based on the structure, their reactivity will also be different. First, let's analyze the statement A. Morphine on treatment with 2 moles of sodium hydride and 1 mole of methyl iodide gives codeine. Is this a correct statement? See, you don't have to write the overall structure to answer this question. Since this is phenol group, right? So I will write this as like this PHOH. So I'm referring to this particular part of the molecule. Now, when this is treated with sodium hydride, what happens? The sodium hydride is a strong base. So we know that phenol is also considerably a strong acid, right? So with what you are comparing here, you're comparing it with an alcohol, right? So it will react with the sodium hydride and what it is going to form? A sodium phenoxide. The byproduct will be hydrogen gas, okay? So this is a sodium phenoxide you get. What about here? This is an alcohol, right? So only this part is reacting. Therefore, I'm going to write it as an alcohol, ROH. Okay, it doesn't matter what is this group. Now, when this is treated with sodium hydride, which is a strong base, again it is going to form an alkoxide, sodium alkoxide, and the byproduct is hydrogen gas. Why so? Although alcohol is weak, sodium hydride is strong enough to react with our alcohol and it will form a sodium alkoxide. That means what? Sodium hydride, potassium hydride, Grignard reagent, all these have capacity to take these hydrogens as proton. Now, when these two are reacted with methyl iodide, what will be the general reaction? This is a nucleophilic substitution reaction. How do you know that? See, this is a nucleophile. It should attack here. Iodide should leave. So it is a simple nucleophilic substitution reaction. But we have two nucleophiles. Which is going to react? So that depends on the nucleophilicity. What do you mean by nucleophilicity? The nucleophile which is stronger will displace this iodide. So which is a better nucleophile among these two molecules? How do you know that? See, here we have phenoxide, right? What is the structure of phenoxide? A benzene attached to O minus. Now this O minus is stabilized by resonance, right? So that means what? The negative charge is being stabilized by the benzene ring through resonance. That means it is not a good nucleophile. The nucleophilicity decreased, right? So this is a bad nucleophile. You can say like that. What about this one? The electrons are localized. Here the electrons are delocalized. Here the electrons are localized. Hence, it will attack the methyl here and then iodide will leave. So among these two, alkoxide and phenoxide, the alkoxide is a better nucleophile. Hence, the methylation happens over here. So this is what we are going to get. Right? But is this the correct structure of codeine? No, it's actually the other way around, right? Therefore, this is not the correct statement. Now option B says that morphine on treatment with one equivalent of methyl iodide gives codeine. Is this correct? Not really. So here it's very important to convert this hydroxyl group to a phenoxide. Similarly here also, it's very important to convert this to alkoxide. Only then they will attack the methyl group and then it will undergo nucleophilic substitution reaction. And moreover, with only 1 mole of methyl iodide, we are not even able to decide where the methylation will happen. So this is also not correct. Now let's check for the option C. Morphine on treatment with one equivalent of sodium hydroxide and one equivalent of methyl iodide gives codeine. So here the equivalence is pretty important because selectively we are doing the methylation on the phenol, right? How to do this is the correct method is what is shown in option C. See, between a phenol and an alcohol, phenol is more acidic. So let's make use of this point and selectively react phenol with the base. What kind of base are we going to use in that case? Sodium hydroxide. The sodium hydroxide is strong enough to react with the phenol, okay, but it is weak enough to react with an alcohol because alcohol is weak acid. Okay, therefore selectively it will react with this part of the molecule. That means what? You are going to get the phenoxide. Since there is no other possibility, right, it has to form this phenoxide part here. And since we are treating this with the methyl iodide, what happens here? It will undergo nucleophilic substitution reaction. Hence the methylation will happen here. Hence the product will be codeine. You can ask yourself, here the methylation did not happen, right? Here it is happening. How is that possible, right? So here the comparison is between alkoxide and phenoxide. That's why we have this possibility. Okay. Here the formed whatever negative charge, even though it undergo delocalization, right? It still has to react with methyl iodide means what? It is undergoing nucleophilic substitution reaction eventually, and then it will form the codeine. That's the reason we do get the codeine as a product. So you can again see here, we are using one equivalence to make sure that the methylation specifically happens on this particular oxygen. Now let's see the last part of the question. When morphine on treatment with excess of acetic anhydride, it gives heroin. Is this a correct statement? Yes, it is correct. How so? Because whenever you have acetic anhydride, the acetic anhydride structure is this. Okay, it's also written like this. CH3, COO, COCH3, right? Like this. So you can see that this part is considered as acetyl. So that's why it is written as AC twice O. Okay, don't get confused. All of them are same. Acetic anhydride. So when this is treated with whether an alcohol or the phenol, here the acetylation will take place. So you can see that if you are using like this, okay, so you can see it will undergo acetylation like this. So here it could be either pH, okay, like a phenyl or any other alkyl group, whatever it is. So you see this will undergo nucleophilic substitution like this, okay. So you are going to get an acetylated product. So this can be written as AC. That's what I meant earlier by this structure. So that's why you see here, this is acetylated product. So that's why the acetylation happens on the phenol as well as on the alcohol. Hence, the statement D is also correct. This is a reason why the selling of acetic anhydride or buying of acetic anhydride from the normal chemical shops is actually banned, because so this acetylated heroin is a kind of a strong drug, right? So in order to avoid the preparation of such drugs, so the acetic anhydride is banned. And please do remember, these molecules are used in a very small concentration and that to treat the diseases. Otherwise, they must not be consumed as they are very, very addictive. I hope this video helped you to understand the reactions and the disadvantages of these molecules. And I have included one more question at the end of this video. Please do solve it. And if you still have any questions from organic chemistry, you can ask your doubts in the comment section. Thank you for watching this video. Until next time, and don't forget to subscribe the channel.